In this video, we use the solution to the differential equation, or excuse me, the solution to the initial value problem we found in the last video, to answer the question posed in problem 3.5.3 from Nagle's Fundamentals of Differential Equations, 7th edition. So in the last video, we solved the IVP. We found this charge as a function of time, but we didn't answer this question. The question at the very end says, if the capacitor is initially uncharged, which means that at time t equals 0, the charge on the capacitor is 0, and the transmitting gate changes instantaneously from 0 to 5 volts. So that's saying at that moment, t equals 0, this is going to be equal to 5. The question says, how long will it take for the voltage at the receiving gate to reach 4 volts? Now, to understand this, you have to remember what the receiving gate is. At the beginning of our problem statement, it says, the pathway for a binary electrical signal between gates in an integrated circuit can be modeled as an RC circuit, as shown in the figure. The voltage source models the transmitting gate, so this is acting as the transmitting gate, and the capacitor models the receiving gate. So when it says, how long will it take for the voltage at the receiving gate to reach 4 volts? It's basically saying, how long will it take for the voltage on the capacitor to reach 4 volts? That's actually pretty simple. Remember, the voltage drop across a capacitor is given by this formula. E sub c is that voltage drop. So we want to know when that's equal to 4. We know the capacitance, that was given in our problem statement, and we have this Q of t, that's our charge as a function of time. If we substitute all of those into this equation, we'll have an algebraic equation involving t, and we can solve for t, which will tell us how long it will take for the voltage at the capacitor to be 4 volts. So we're just substituting into this equation. We want the voltage to be 4. The capacitance was 10 to the negative 10 farads. And you can multiply both sides by 10 to the negative 10. And then you'll have that the charge on the capacitor, which we found in the last video to be this, has to equal that 4 times 10 to the negative 10. Now, in order to solve this exponential equation, I just need to subtract this from both sides. If I have 4 of those and I subtract 5 of those, that means I'm going to have negative 1 of those. It's just an algebra problem, really, at this point. And I'm trying to get the exponential function by itself, so I will divide both sides by 5, or negative 5 times 10 to the negative 10. Negative divided by a negative is a positive. And the 10 to the negative 10s will actually reduce. You can think of this as negative 1 over 10 to the 10th divided by negative 5 times 1 over 10 to the 10th. If you want, you can multiply both sides by the reciprocal of this, or excuse me, not both sides, multiply the entire fraction by the reciprocal of that. So you can multiply the numerator and denominator by 10 to the 10th. And you'll have negative 1 divided by negative 5 equals this. So we have 0.2 there. And we're trying to get t by itself. So to get rid of the log, we'll take, or to get rid of the exponential, excuse me, we'll take the logarithm of both sides, because to undo exponentials, we use logarithms. Whoops. Those two functions undo each other, and we would just get the exponent back. And to isolate t, we'll just divide by negative 10 to the 8th. and we get approximately 1.609 times 10 to the negative 8 seconds. Pretty fast.